Hello everyone, I'm Min-Kook Choi, research engineer from Hutom Vision AI. Our research was conducted in collaboration with KAIST SIIT Lab. I would like to thank everyone who participated in the research. The most widely used knowledge transfer is transfer learning, which uses pre-trained weights trained on large-scale dataset as the initial value for new tasks. Another representative example of knowledge transfer using CNN is knowledge distillation. However, the two main transfer learning techniques depend on the model structure or dataset. In this work, we consider the transfer learning technique that can overcome these limitations. Our research is on the line of existing works, transfer learning with pre-trained initializer, KD, deep mutual learning, auxiliary learning, self-supervised learning, and domain adaptation and expansions. Although transfer learning using ImageNet has been successful so far, questions on transfer learning using ImageNet have been raised in previous research. The experimental results of object and key point recognition problem have been reported as examples where the pre-trained initial value do not convey additional knowledge to the different problem domains. From these limitations of transfer learning, we devised a novel approach to perform knowledge transfer in different ways. To enable a more efficient transfer of pre-trained knowledge under relaxed conditions, we propose a simple yet powerful knowledge transfer methodology without any restriction regarding the network structure or dataset used, namely SSKT. The CNN responses that can be obtained from the same image vary depending on the type of supervision. SSKT performs auxiliary training using software able to convey the previous trained prior knowledge from the source task. The gradient to update the weights of a target network is obtained as a linear combination of all losses. The main training scenario for SSKT are divided into four categories: single source, heterogeneous problem domains, multi-sources, and heterogeneous structures and problem domains. For the auxiliary task loss, cross entropy and KD losses are applied, and the gradient update is applied like a blue box. To encourage the prediction of auxiliary loss from the source task, we design a MAXL structure-based transfer module that supports an auxiliary task using the feature output from each convolutional block. For an example of a ResNet-based module, each output of the res block is encoded as a fixed size output by bottleneck and average plane, and finally, each feature output from the transfer bottleneck is summed. The transfer module used in SSKT consists of a summation of feature output of bottleneck layers from each convolutional block. We applied the transfer module to four different CNN architectures such as ResNet, DenseNet, MobileNet, and 3D ResNet for each problem domain. We tuned hyperparameters for the temperature parameter T included in auxiliary loss, the balanced parameter alpha included in the total loss, and the presence of the transfer module. To verify the SSKT, we designed a series of experimental scenarios. Table 1 summarizes the experimental settings for the verification of the SSKT. Tables show the performance of learning from scratch and SSKT for the image classification problem on CIFA-10, 100, STL-10, ImageNet, and Pascal VOC datasets. For knowledge transfer between image classification problem, the use of the SSKT improves the generalization performance on all the tested dataset. In particular, the highest performance improvement was obtained when the multi-source networks were used simultaneously. Table 5 shows the performance of learning from scratch with the 3D ResNet on UCF101 and HMDB51 datasets. Note that the auxiliary task in SSKT prevents overfitting during the training of the 3D CNN model. Similar to other SSKT settings, the performance improvement was highest when using a multi-source networks. SSKT is even possible between structurally complete heterogeneous networks such as 2D to 3D CNN knowledge transfer. We validate the SSKT using several knowledge transfer scenarios based on a CNN. For further investigation of the SSKT, depending on the target task where knowledge transfer takes place, additional consideration for the transfer module design must be made. Variation in the data transfer function f for the source networks may be another avenue worth pursuing. Thank you for your attention. Our source and additional experimental results are publicly available on the web. Thank you.